welcome to this video. My name is Luis Arturo Vélez and I'm a student at the National University of Mexico. I'm currently cursing my 6th semester and I'm gonna talk about electrical machines, which is one of the subjects I took. I think it is a very interesting topic because it allows you to understand how transformers work, which was my favorite topic of the course, because transformers are a very important element in any network grid because they allow you to change the voltage and current characteristics without altering the frequency. Another very interesting topic is electrical motors, specifically induction motors. And I'm gonna be showing you a few examples of induction motors in my house. The first example is a fan, another example is the washing machine, the fridge, and the water pump. The water pump in my house is a monophasic induction machine. It consists of a frame where inside you can find the rotor and the stator. The characteristics of my water pump are a current of 5.5 amperes, a voltage of 115 volts, a frequency of the network of 60 Hz, and it's got a power of 0.5 HPs or horsepower. And finally, the efficiency of my water pump, according to the specifications of the manufacturer, are 59.5%. To know the inner characteristics of an induction motor, there are two tests that need to be made in order to know the resistance and inductance values at the stator and the resistance and inductance values at the rotor. It is important to mention that this representation is only of one of the three windings that can be found inside of an induction motor. So just keep in mind that this is a single winding, but in real we have three windings just like this. Another important characteristic to keep in mind is that the parameters at the rotor are referred to the stator by the constant A, which is the number of turns the winding has at the stator and at the rotor. And another important concept is the slip, which is the difference between the speed that the rotor has in comparison with the speed at the stator. The first test is the no-load test. This test allows us to find the values of the magnetizing resistance and the magnetizing inductance, remembering that this is the approximate representation of a motor. For the test, the connection diagram should be like this one, where you would need to measure the power of two of the windings of the motor, as well as the line voltage and the three currents flowing through the windings. Then the relationship you would have to use to find the line current would be this one, where you basically just add up the three currents and divide them by 3, and the line voltage would be this voltage. And finally, the power would be the measure of your wattmeter here or your wattmeter here. For the second test, we need to put a load big enough to block the rotor. In other words, we need to ensure that the rotor won't be rotating and its speed will be 0. The diagram connection for this test is pretty much the same as for the no-load test, where the rotor had no load, and we need to measure the line voltage and the line current. We would need a voltmeter, a wattmeter, and 3 amp meters, where again we would need to find the line current, the voltage line, and also the line power. With these measures, we would be able to calculate the equivalent resistance of the rotor and the stator and the equivalent inductance of the rotor and the stator. After performing these two tests, you will be able to find the equivalent approximate model of an engine. For more information, you can refer to Electrical Machines by Chapman. That's all. Thank you for your attention.